Good afternoon, everyone. We're going to go ahead and start off with reaction types. We want to make sure that you have all the information you need to get started with this unit. Now, you're also going to notice that the concepts are going to come a little bit faster because it's going to be a little bit less math-based. It's still going to be some math and some memorization, but it'll be a little bit less math-based, and we'll get to more of the conceptual side. So it'll be more about the reading and understanding what's going on, and less about the having to do extraneous calculations. Now, with reaction types, we need to go into three main types that we're going to talk about. Now, those three main types, of course, break down a little bit further, but we'll talk about that as we get into it. Now, our learning goals for Section 1 are going to be this: 3.02, which again can be found on your tracking sheet, and 3.03. This is going to give you the basic information that you need to go through that. Some of it will be directly on the slide, and some of it will be things that I'll be saying directly to you. So let's go ahead and get started. Now, when we talk about any type of reaction, most times we're going to have it occur in water. Remember we talked about aqueous solutions. You heard that term aqueous before. Now, because water is critical for almost every process that goes on in our body and a lot of things that go on the earth around us and the world around us, we have to figure out, why is water so important? What is it about the properties of water that allow it to be so useful in so many different areas? Now, the first thing that we're going to look at is the fact that water is a polar molecule. Now, what does polar mean? Well, think about it. Poles. If we think about a magnet has two poles. It has a north and a south pole. It has two different charges or two different sides to it. In the same way, as we look at our diagram here on the side, we'll look at the fact that we're starting to see, realize that's a little bit harder to see. We have a slightly negative side along with a slightly positive side of water. Let me go ahead and change that color so we can see it a little clearer. So here we go. Try that again. All right. So slightly negative, slightly positive side to our water molecule overall. Now, this is going to be due to the unequal sharing of electrons. With one of the things that we're going to cover in the next unit or next couple of units is we're going to talk about electronegativity, or the ability of one atom to pull electrons or attract electrons from other atoms. Oxygen has a much higher electronegativity than hydrogen has, giving it a slightly negative charge because it's going to pull those electrons. Think of tug of war. It's going to pull it closer to the oxygen atom. Now, this is going to create why we have our slightly positive side on our hydrogen. Because of the fact that these electrons are being unshared and they're being pulled away, hydrogen only has one electron to hold on to anyway. So it becomes slightly positive, or more of the positive nucleus is shown or displayed. Now, this gives us the opportunity to be able to dissolve polar substances. Notice that I'm saying it can dissolve polar substances. That's a key. You want to make sure you have that written down. Polar substances. If it is a non-polar substance, like a fat or a lipid, it won't be able to dissolve it. So that's the reason why when you put oil and water together, they separate from each other. They don't interact. But if I have two things that are polar, like water and an ionic compound like salt, what it's going to do is it's going to begin to break it apart, break it into its sodium and its chlorine atoms or ions. Now, aqueous solution, just a couple of definitional terms or general terms. Aqueous solution that we're going to deal with is just talking about the fact that the solution is happening in water, it's dissolved in water. The parts of a solution are actually going to be solute and the solvent. The solute, as you see on the screen, substance that's being dissolved. Solvent is going to be the substance doing the dissolving. Again, most times for us, it will be water. Now, the last term that we're going to deal with, and this is what the two learning goals are really pushing towards, is this term electrolyte. Now, if you've ever played any sports or you watch sports, you always talk about, or when you get sick, the doctor says you have to make sure you keep your electrolytes up. What it's actually talking about is, they're talking about the substances that are dissolved in water that are going to allow it to conduct electricity. Why is this important? Why would a doctor tell you keep your electrolytes up in your body when it's talking about conducting electricity? When we look at different parts of our body, like our heart, our brain, certain parts of our muscles, they respond very quickly to electrical impulse, which our heart, of course, what keeps it going is that electrical impulse. If there's not enough electrolytes in your body, it can start to give you problems. In the same way, we use this term electrolyte when dealing with solutions that actually allow us to dissolve and conduct electricity. So what are my different types of electrolytes that I have to worry about? My first that I deal with is, what if I have a strong electrolyte? Now, this is going to be a substance that's going to completely ionize in water. It's going to break down into its different atoms very quickly. Now, because it does this, that means I have these ions floating around, it's going to conduct electricity very, very well. So if I'm thinking of in terms of having a light bulb, and I apologize for my horrible light bulb, if this is my light bulb, when I run electricity through it, if it is conducted through a strong electrolyte, I'm going to see lots of bright, bright light. Now, what about a weak electrolyte? Now, weak electrolyte ionizes only slightly, as you see, less than 5%. So it's only going to conduct a little bit of electricity. So going back to my light bulb illustration, it's only going to get just a little bit of light coming off of it. It'll still light up because you still have some ions that are there, but it's not going to ionize as quickly. These are going to be things like maybe your weak acids, weak bases. And you have your non-electrolytes. They don't produce any ions. Because of that, you actually get no current flow when they're dissolved in water. Now, this is what we're going to use to base the rest of our material off of. Again, strong electrolytes. We have our strong acids, our ionic compounds. Our weak electrolytes, things like our weak acids, weak bases, some other materials. And then last but not least, our non-electrolytes, these things that don't produce any ions. And this is going to be very key as we continue to move through and look at our different types of reactions. That's where we're going to end it for today. I look forward to hearing from you. Write down your questions. Please write down your questions. I want to make sure that you understand what's going on and that I can do anything I can to help you to be prepared for your exam. Have a great afternoon, and I'll see you in class.